Dear students, in this class, let us discuss how to verify the hardware result, that is experiment results of PN junction diode and Zener diode VI characteristics with the help of multisim simulation tool. You all aware of multisim simulation tool because you have studied in the electric circuit analysis laboratory itself. So let us start the experiment. Start here and you select multisim 11 software tool. Wait till it is opening. So you have to connect all the component as you have connected in the experimental setup. So after opening this multisim simulation tool, you have to select all the components from the library. That is, what are all the component required that you have to select from the library. So you can see here, you can able to note here the supply is there, resistor, diode, transistor, gates, everything will be available. And here you can see the measuring instrument available over here, right? So for our experiment, we need resistor. So that is VI characteristics of semiconductor diode. So for that, first I am selecting 2.2 kilo ohm resistor. You can see here, after clicking this resistor, this master database will open. So in this master database, the basic component is there. So here if you click this resistor, you can have this type of page. So we need 2.2 kilo ohm, so I am typing here 2.2, so you can get 2.2k and click OK. So you can have a resistor 2.2 kilo ohm, and afterwards we need diode. So for that you go for, in basic you can have a diode. So if you click like this, many diodes will be there. So in that we have to select IN4007. You can search like this, or else you can type IN4007. IN4007. Sorry. IN4007. So you can see, you can find IN4007 here and click, close it. You can get IN400 diode. So again you click go for master database, and we are in the need of the measuring equipment. So that is, you go to the indicator. In that you can find voltmeter. So in voltmeter you select horizontal -H. So that is voltmeter. And next we need ammeter to measure the currents. So you click ammeter and go select the ammeter -H, click OK. You can have ammeter. And in source we have to take a DC source because we are analyzing VA characteristics, that is DC analysis. So in source you click power sources. In that you take DC power. So click OK. You can get power. And ground also we need. So all the circuit must be grounded, then only we can get a closed path. So you click ground, click OK and paste it here. And that's all. These are all the components we need to connect to make a circuit. So in aligned manner you keep all the components. So from the supply you connect the resistor. From the resistor other end you connect to anode of the diode. From the cathode of the diode you connect to ammeter positive. From the ammeter positive you connect to the negative of the supply. And across the device we have to connect the voltmeter. So you connect like this, right? So after connecting all the elements in the circuit, you connect ground. Don't forget to ground. And Initially, to analyze the characteristics, we have to start with the supply voltage as 0. So double click here, you can get a box like this. So here you type the value as 0 and click OK. Now the supply is 0 and you click here, you can see the green color button. So if you keep the cursor there, you can have run bar simulation. Now you click run. So if the voltage is 0, the forward voltage and forward current is 0. Now we have to vary the supply voltage. So for that you stop simulation and double click here, vary the voltage. I am setting it as 3 and click OK. Now simulate. Now you can note the forward voltage and forward current. So likewise, for all the applied voltage, you have to measure the forward voltage and forward current, right? Now stop simulation. The same way we have to analyze the reverse characteristics. You click the diode and Control X, Control V, keep the diode here and then Control R, reverse the diode and keep it like this. Now you connect the supply to the negative of the diode, that is positive supply to the cathode and anode to the ammeter positive. Now you make the supply as 0, click OK and simulate. So for the applied voltage 0, the reverse voltage is 0 and the reverse current is also 0. Now further we can increase the voltage by double clicking this value and keeping it as 5. Click OK. Sorry, before that we have to stop the simulation and afterwards you double click here and the applied voltage is 5. Click OK and simulate. So the corresponding reverse voltage and reverse current we can able to notice. So if you see here in reverse characteristics, the diode will act as a blocking mode. That is, the diode will be in blocking mode, so that the reverse voltage will be more and the current will be in microampere, right? So likewise we can further increase the applied voltage and keeping it as 10. Click OK and simulate. Now the reverse voltage is 9.9 and the reverse current is, that is, we used to get a reverse leakage current only, that will be in microampere, so that is 1.032 microampere, right? So likewise we have to compare the experimental results with the simulated one. Now stop the simulation and go to the file and save your file with your name, like simulation of VA characteristics of semiconductor diode. You can save your file.